morning and welcome to the 23rd annual exhibit of hydrogen and fuel cell technologies and batteries. We've been here for quite some time talking about innovations, about ways to use hydrocarbons in general, hydrogen and fuel cell technologies. We have specialists to address this very specific technology developed recently and now marketed. It's Convion's first 50 kilowatt solid oxide fuel cell system using CFY-stacks developed by Fraunhofer's Institute for ceramic technologies and systems. Please welcome with me Dr. Mihails Kusnezoff, who is head of the Department of Material Components at Fraunhofer's Institute for Ceramic Technologies and Systems. To my left, next in line, please welcome Tuomas Hakala, who is the co-founder of Convion in Finland. And last but not least, Siddharth Mayur, who is founder, CEO, and president of mPower in India. So, perhaps we could begin with the general information, the presentation of who you are, how you came to be involved in this project. Michael?
Yeah, thank you for a kind introduction. So I'm working at Fraunhofer IKTS since '95 and concentrated on solid oxide fuel cell technology. So we have started the development of CFY-stack together with Siemens and then continued 2005 with and brought it to commercial product, which we can license. And our first licensee is the company mPower, which now is responsible for distribution of this technology.
Okay. Tuomas?
Thank you. My name is Tuomas Hakala. I'm a co-founder of Convion. Convion is a startup company commercializing fuel cell systems for distributed power generation. It's a fairly young company, but the founding team has a longer history together. We used to be part of a Wärtsilä corporation and their fuel cell activity that started soon after year 2000. So there's quite a bit of background there. All along we've focused on the system technologies, system controls, power electronics. We don't develop our own stacks or cells, but we worked with a number of developers of stacks and cells. And the market segment that we are aiming at with this 50, 60 and plus kilowatts is industrial and commercial applications.
Okay. Siddharth?
mPower, we are a one-year-old company. We are found out of Fraunhofer's technology that was developed along with Plansee. And we debuted here last year, actually.
Yes.
That was the first time we went public. And for a one-year-old company, we have already a 50 kilowatt system that is developed using the stack technology. Is in itself a big testimony of the technology that we have inherited from Fraunhofer and Plansee. And our focus and aim is to commercialize this, make sure that the technology gets cheaper in terms of cost, and we are able to give value to our customers like Convion to build systems in a much more simpler and easier manner. So for mPower, the focus is to provide solutions which are beyond electricity.
Michael, solid oxide fuel cell systems, of course, they've been around for quite some time, but they're always improving. Work on this CFY stack has been going on for some 15 years, I understand,
yes.
Continuously improving the technology. So what were the challenges and what were the improvements that you managed to initiate while working on the stacks?
Yeah, I think that there are three main improvements we have made during the last 15 years. And the first is connected with bipolar plate produced by Plansee, which could be made in net-shape technology, which allowed the to reduce the cost. Then we have developed a high power density cell, which is based on scandia-doped electrolyte. And the power density of this cell at operating temperature of 800 degrees C is comparable to that of anode-supported cell. And the third one is a stack technology, which is rather simple to assembly, and the stack has not so many parts, and it means that we can reliably build stacks which can also be multiplied in big modules.
So, of course, for things like stationary applications, durability, reliability, lifespan are like fundamental issues. A stack itself, of course, does not a system make, and they have to be integrated into marketable applications. I believe that's where you come in, looking at the prospects and the integration of the system. What were the challenges you faced?
I think the overall challenge everybody has to mention at some point is cost, and cost of complexity, cost of lifetime, or like overall insufficient lifetime, and these things must have been improved. What we have focused on very much on the system side is simplification of the process itself, remove as many parts as possible to build the cost potential, and also simplify the interfaces. If you think, we like to say that the 60 or 50 kilowatts is a large fuel cell system, but in terms of power generation, it's still quite a small generator, and therefore you really can't dedicate very many maintenance personnel hours per year for a single system. So you want predictability, long maintenance intervals, and as simple interfacing systems as possible. For example, to mention one thing is the completely waterless operation. We don't need water at all, even for startup, as many do, which you would think water is something simple. We see it everywhere, but to build an extra system just for the startup or shutdown hours is a fairly significant cost item and a maintenance issue. So the simplicity is what we have been aiming at, and I think by adopting the approach of focusing on the system side and being able to utilize all the advances in the stack development has put us in the place where we can now start shipping systems to customers and showcasing them in replicable applications.
Of course, 50 kilowatts is relatively small if we're talking about large grids, yes, centralized power systems for large grids, but of course in some contexts, small is beautiful. Local production, local consumption of energy is every engineer's dream. It simplifies a lot of things. You have applications specifically for the design that is marketable right now. It's a consumer product.
Yes, and the best part of the development also and the stack technology is that we can take in multiple fuel options. And one of the things that Convion has achieved with this development is developing a biogas-based fuel cell system. So that really opens up a wide market where you can get the waste which is available everywhere and convert the waste into biogas and use that biogas directly to convert into energy. So that really makes the whole story complete in every sense of terms. And that way we can look at distributed power generation, we can look at going on islanding mode, we can go to every building or we can go to every house, every farm. And we're trying to do this. We are working with Convion jointly to replicate this in India. We are looking at installing systems in agriculture sector in India, in commercial sectors in India. So this is going to really open up opportunities not only in Europe, but it's going to open up opportunities for countries like India or in Africa or South America to leapfrog on technologies and go to the next level.
I like to stress, because I've seen this misinterpreted, people confuse biodiesel, which is the use of crops in order to develop something that you can use in a diesel automobile application. We're talking about the waste that gets wasted. Okay, the energy that we throw away because we do not recuperate the hydrocarbon potential in the junk that we toss out. And why I find this very interesting is because, and this is my question, there is a business model where we're not initially competing with the existing wonderful grid structure in European cities. That is, we're recuperating assets that are being wasted. And this technology is just admirably designed to do this. Do you have any ideas of how this integration, and when I say integration here, I don't mean system integration of the stacks, I mean integrating these units into the cycle of waste close to where the junk gets tossed away. We're talking about human waste, we're talking about biological waste, it could be a lot of things. Are there any examples there that you could name where this is done already or where you're approaching this?
If you think of wastewater or even municipal solid waste processing, there in Europe and in North America, many of the big plants are already there, and they're admirable installations of conventional technology because the large scale makes possible to optimize piston engines or turbines as well. But where the untapped potential is are smaller or medium-sized communities. That's where we are not only recycling something valuable, we are actually upcycling, because otherwise waste stream needs treatment, which is a cost. It's a cost only. So it's the lowest value, and there's even a cost involved. And we can now become energy neutral in waste treatment, or even become net producers of energy. And where fuel cell technology, where the particular competitive differentiators of SOFC technology are highest is the small scale, where conventional technology would not have the efficiency needed for continuous operation, and where the other alternative would be to upgrade the gas as biomethane to the pipeline. That also has a cost. Utilizing it locally, that's where we don't even have to go to places like India or Africa. In Europe, there are thousands and thousands of underutilized sources of such bio streams.
Do you think of this as a sort of commercial entrance potential? Of course, and we'll get to the topic here, solid oxide fuel systems, they eat anything. They're very flexible by comparison with the PEM cell, which is very fussy. It needs pure hydrogen. I mean, it does a lot of things with just about any type of fuel. But here, the question of finding a market that allows you to commercialize a product, that is, to get the numbers out there, to start manufacturing not 2 or 10, but hundreds, and potentially thousands of these units. So is this specific application an entrance way into commercialization, or do you have other things in view to commercialize the product parallel to the bio-waste?
Well, you may continue, but basically our product is a fairly generic building block. So it's not limited to biogas, but biogas is one of the very attractive applications because it has a potential of opening up new applications and new business models as well. We believe that biogas in suitably sized installations is a way to enter the market and to get the numbers of cells and stacks and systems ramped up. And there, the benefit of that ramping up will also be reflected to other applications.
And looking at biogas, you're also talking about natural gas. We are also talking about liquid fuels. We are now working to test whether I can use liquid fuels with our stack technology. And that is going to open up a large market and a very different niche in different applications that we're talking about. And taking this forward, what Convion is also doing, the 50 kilowatt is an entry product. And the beauty of SOFC technology is that you can scale it up and scale it down without really affecting the efficiency. So you can get the same juice out of a 1 kilowatt system, the same out of a 100 kilowatt or a 50 kilowatt. And that is where our focus is now, to get it to more commercialized level. mPower as a company would also start manufacturing the product sometime in 2018 on our own in Dresden. And those steps will really take care of the cost criteria, which is the biggest impediment for mass commercialization of the SOFC technology.
Michael, it's already been mentioned, the solid oxide fuel cell systems, they're scalable, they're flexible, so they're for many markets. But you have here 2 strategic partnerships. Of course, Fraunhofer is interested in commercial applications of the things they develop. You guys don't like to sit in the offices and do the R&D alone. Yes. It's nice to get out into the real world and see people making a few dollars on this and see a successful product that is also environmentally attractive. How did you approach partnering with these two gentlemen to the left? Was there something about the design that, or was it just a fortuitous collision of forces? How did you approach the business side for collaboration?
I think that is always all together. So you need all of them to make a successful deal or to generate successful business. But we had a very good development of the stack in terms of reliability and robustness. And it means not only that we can provide 1 or 2 or 5 stacks for testing, but we can also manufacture 100, 200, 300 of them. And then the second point is also the long-term stability or redox stability, because at the beginning of the development you should rely on a product which can survive emergency shutdowns and all system failures and so on. And this stack gives this opportunity. And this is also the reason why we could generate the first markets, and we could also put the stack in a rather complicated system for SOFC world, because 50 kilowatt systems are not so often or not so common. And I think that performance of the first systems shows that this is the right way.
Of course, the size of the system you've chosen here, we're talking about the 50 kilowatt system, it is scalable nevertheless. But is there any specific reason for choosing that size? Is it because it's a standard for specific applications?
Well, there are a number of reasons why we chose this segment. One thing is that if you consider the application and what is valued by the end user, often if you consider residential buildings, electricity is assumed, but you are not willing to pay very much extra for example, like extra security of supply. In many of the commercial settings, you either have to invest into a backup genset or battery pack or something, and therefore this added value of reliability and capability of going into an island mode and securing the loads is valued. And on the other hand, if you consider the competing technologies in this power range from 50 to say some hundreds, the piston engines or the turbines would have significantly lower efficiency. Once you go up into the megawatt scale, that's where the conventional technologies are quite optimized. So again, it's an entry product, entry to this market. Eventually, this technology will conquer all sizes and ranges, I believe. But for us, this is an important scale to differentiate ourselves and to highlight the values of on-site power generation.
Siddharth, well, we were preparing the talk. We mentioned 2 places, Italy as an example, and India. We know there's a European market because, as you mentioned, there are smaller communities where the bio-waste question is not solved, where there's a available resource that is simply not being harvested. So, Siddharth, to you the question. Within 1 minute, if you can explain that. So, the future of this technology, is it going to pick up more quickly in India or in Europe? Or are you agnostic about that question? It may be both.
I believe it will pick up a lot better or a lot faster in India, because in India we currently have energy deficit. There is energy starvation. So for us to leapfrog to a technology which can get us energy independence and get us 24/7 energy is also the focus of the government of the day and is the requirement. So we believe that as compared to Europe, also the size of the market in India is much larger, and that's the reason we are doing pilot scale installations. We are looking at doing 2 installations in India, and with those 2 installations I believe we will be able to generate a lot of interest, especially on the biogas side.
We've unfortunately run out of time, but I encourage everyone to continue the conversation at the booth E51. I hope you gentlemen will all be available there for continuing conversations. It's been a fascinating talk about the solid oxide fuel system, CFY-stacks developed by Fraunhofer's Institute for Ceramic Technologies and Systems. I've been talking to Mihails Kusnezoff, you're from Fraunhofer, Tuomas Hakala, who's co-founder of Convion, and of course Siddharth Mayur, who is the founder, president, and CEO of mPower in India. Thank you very much for being here, and I hope to see you back next year.
Thank you.
Thank you.
Thank you.
It was a pleasure.
And thank you all for being here. We are going to continue in seconds, literally. Our next talk is going to be Dr. Alexander Friedrich, who is from the Deutsche Zentrum für Luft- und Raumfahrt, and they'll be talking about cost reduction in materials, developments, and system design with my colleague Michael. Stay tuned, back in a minute.